Okay, I am starting on page 54 in your book. I know that I'm skipping a bunch, but you can do this. So, when I look in this first box, I'm looking at this equation. And right now this equation is in factored form, and you can tell it's in factored form because it has all of these parentheses. Okay, so that becomes important. I know that the degree of my function is x to the third. It's a third because there's 1, 2, 3 x's. I know that the leading coefficient is 1 because there's no numbers in front of those x's to multiply. Okay, I'm looking at a third graph, and a third graph starts from the bottom. Now we here. And so it goes from down to up. To find my y-intercept, I'd have to go and multiply, but I'm going to teach you a shortcut today. So if I multiply that number times that number times that number, I get my y-intercept. So negative 2 times 2 makes 4, negative, and negative 4 times 1 makes negative 4. So that's my y-intercept. I'm going to go put that on my graph. Okay, so that's something new we learned today. If you really want to, you could make the boxes and get all the way to standard form before you find your y-intercept. My roots come from each of those 3 parentheses. So I'm going to take the opposite of what's in them. So here I get 2, negative 2, negative 1. Notice it's the opposite of what's in them. And then each of them have a multiplicity of 1 because they each only have 1 parenthesis there and no exponents to tell you that it's more than that. So I'm going to go put those on my graph as well. Negative 2, 2, and negative 1. Okay. So then they want me to go and they want me to draw something to help me figure out where to put things. So they want me to go ahead and plug in these numbers. The reason why they picked negative 3 over 2 is because that's the only thing that's in between there. And I know it's a fraction and I know that's gross, but we're going to do it anyways. So negative 3 over 2 minus 2 times negative 3 over 2 plus 2 times negative 3 over 2 plus 1. Okay, so I'm actually going to change these to decimals because that just looks so much easier to me right now. Negative 1.5 minus 2 makes negative 3.5. Negative 1.5 plus 2 makes positive 0.5. And then negative 1.5 plus 1 makes negative 0.5. I'm going to take a calculator and I'm going to multiply those all together. When I multiply these all together, I get 0.875. So almost 1. I'm going to go put this at almost 1 on my graph. And I'm going to make sure that I put down 0.875 in that box. So now I have to do it all over again, but this time I get to do it with a positive number. I get to do it with something that's not a fraction, so that's super nice. So I'm taking this and I'm plugging it in for all of my x's. That's what I'm doing, if you were lost last time. So then I have 1 minus 2. I have 1 plus 2. And I have 1 plus 1. 1 minus 2 makes negative 1. 1 plus 2 makes 3. 1 plus 1 makes 2. Negative times positive 3 makes negative 3. Times 2 makes negative 6. So I put that there. At 1, I get negative 6. Okay. So then my graph goes something like this, where I started from the bottom, and then I moved upwards. Okay, notice that my end behavior matches. It starts down low, it goes up high, and I get that cubic looking thing. So They want to know were those relative maximums or minimums. So this right here is a max. This right here is a min. Neither one of these are absolute. Both of them are relatives because both of them have arrows that go above them or below them. Okay. So I'm going to leave you this one to do. Again, you're looking at leading coefficient is multiplying, and I end up with just a 1. My degree here is a cubic. I know that this is normal. It goes from the bottom to the up because this is a positive. I know my y-intercept happens when I multiply all of these together. So here I get -4 as well. My roots go and they take on opposites. So I get roots of -2, -2, and +1. So do you see how they don't have enough boxes for me right now? That's because I used my -2 twice. And I need to make sure that that has a multiplicity of 2. So notice that this parenthesis matches that parenthesis. When I go and I put that on my graph, I get -2 there, and I know that I'm going to have a bump or a bounce that happens. I know that this right there is my y-intercept, and I know that this right here is another one of my zeros. So then it asks me to go and check -1. So at -1, I'm going to plug that in. And you'll go get an answer for that. Then I'll do it with -3. At -3, I'll plug that in. And you'll go get an answer for that. Okay. So then it's going to ask you if you need those points, and you don't really because you can sketch right now, but those points make your graph more accurate. Okay. So then we look right here. This time I have 1, 2, 3, 4 x's. This is going to make an x to the 4th. You should have 4 roots, but you'll notice that you only have 2 because this repeats and that repeats. And so you end up with multiplicities of 2 on both of those. This is a normal x to the 4th graph. It's got a positive in the front. So it's going to make some sort of happy face. We just don't know what kind. So then here they want you to come up with points to test. So if I'm looking at roots at -2 and at +1, I'm probably going to test the point 0. And I'm probably going to test the point -3. And I'm probably going to test the point 2. Trying to find the easiest points to test that are in between all of those dots. Okay? They only asked for 2 of them. I'm telling you, go ahead and make that 3rd one. Make it happen. So then right here I have 1, 2, 3, 4. Again, this is a 4-degree function. My leading coefficient, notice, is a -1. So this is going to make this sad. It's going to go downwards in both directions. My roots are -1, +2, and +3. My -1 has a multiplicity of 2. Okay, you can do the rest. You can do that page now. They're going to want you to give a bunch of things right here. The reason why is because if I take my x-intercepts on this, there's a bunch of points in between. Go ahead and just pick those points in between. Okay, keep going. You can do this. And that puts me at the end of today. So all you're doing is working. If you need a little bit more help, a little one-on-one, that's what I'm here for. Other than that, we should be okay.